Okay, this is 8.3. This is negative and zero exponents. Now stick with me, folks. We can do this. Zero exponents are this easy. Zero exponents equal 1. That's it. Every single time, zero exponents equal 1. No matter what the power is, no matter what the power may be, if it's to a zero exponent equals 1. 5 to the 0 power equals 1. X to the 0 power equals 1. If you take in parentheses 2x squared and that whole expression is to the 0 power, it equals 1. Now, negative exponents, take a look. Negative exponents don't actually mean negative numbers. Look at what it turned into. A negative exponent gets turned into a fraction. Negative exponent gets turned into a fraction. If it is a fraction with a negative exponent, it doesn't want to be there. Train it to a whole number. Now let me show you what this is. This is not in your note-taking guide, but here's what it is. Negative exponents are never ever happy where they are. That's all it is. It's not that they're negative numbers, they're just negative where they are. Now once they become happy where they are positive again. So x squared right here has a positive exponent. He's a happy person. So he's in the numerator of this fraction and he is happy. Let's keep him happy in the numerator of the numerator of the fraction. X squared, you're staying. Now, y to the negative third power. Y to the negative third power is in the numerator of a fraction, and he's got a negative exponent. That should be like screaming unhappy miserableness to you. Where does he want to be instead? He wants to be in the denominator. Now, once he's in the denominator, take a look. Now he's happy. Positive exponent. Y to the negative third is unhappy. Where would he be happy? Down in the denominator of a fraction where he can be positive. Same thing with z to the negative fourth. Has a negative exponent. He's unhappy where he is. He wants to be in the denominator of this fraction. And once he's there, now his negativity is gone and he is positive again. So let's go to the denominator. Oh, sorry. This is supposed to be y to the negative second. That did not get saved right. X to the positive fourth. X to the positive fourth is in the denominator with a positive exponent. He wants to stay in the denominator and stay positive. It's not just a flipperoo. You just need to make people happy to be happy. Now, y to the negative second is in the denominator and very unhappy about being in the denominator because he wants to be in the numerator. And now that he's in the numerator, his exponent can be happy again. And z to the fifth, not happy. Z to the fifth is happy, Stay happy, z, stay. So only move things that are crying and unhappy. Now, do you notice that you have x's in the numerator and x's in the denominator? You can simplify those, but take a look. 2 x's in the numerator and 4 x's in the denominator. Think about what that would be. X, x, and then 4 in the denominator means 1, not good x's, 2, sorry, 3, 4. This time when we cancel them out, 1 numerator, 1 denominator, look at where they end up. The majority of your x's are in the denominator, so when they cancel each other out, they end up in the denominator, and there's 2 left. Look at your y's. You had 2 y's in the numerator and 3 y's in your denominator. That means you had more y's in your denominator. They're going to end up there with 1 of them. Now, your z's are both in the denominator. You had z to the fourth and z to the fifth. They're both down here, so we need to combine them. That actually makes z to the ninth. Now, do you notice that everybody went to the denominator? Everybody's in the basement. So guess who needs to be in the numerator? If nothing is there, we always put a 1. This would be your final answer. You have as few x bases as possible, as few y bases as possible, and as few z bases as possible, and everything is simplified. So let's try this. 2 to the negative third power means it wants to be in a fraction, because right now if it were in a fraction, it would be in the numerator. So it wants to be in the denominator. Happy. So if nothing is in the numerator, 1 becomes there. Now, the directions do say evaluate. That means find the answer. 2 times 2 times 2. Do not say 6. You should cringe right now if you did. Should be 8. Letter B, blah to the 0 power. And it doesn't matter what blah is because anything to the 0 power equals 1. No joke, it equals 1. Now you have a division problem with a power. We're going to distribute that power out. This is 1 to the negative 3rd power over 4 to the negative 3rd power. That's an aggressive 4. Now you've got some screaming exponents. The 1 has a negative screaming exponent. Where would he be happy? Denominator of a fraction. 4 to the negative 3rd power. Where would he be happy? Numerator of the fraction. And let's solve it. You basically have 64 over 1, which is, wow, that's a bad 6. Don't judge. Woo! 64. Now, letter D is an interesting one. 0 to the negative 7th power, don't instinctively think that this is 0. Negative exponents means this wants to be a fraction. 0 to the 7th power and nothing in the numerator, so I put a 1. The only problem is 0 to the 7th power is 0. Can you have something divided by 0? No, you cannot. This answer is actually dun, 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 undefined. It's not a number, it's not a value, it's undefined. 0, you can never ever divide by 0. That's just the laws of division and math. These are all the properties we've studied so far. You're more than welcome to pause this. I will tell you though, you do not need to know the names of the properties. You just need to know what to do with them. You need to know what to do. So here are some checkpoints. Or I guess these are, yeah. These are using the negative exponents with the other properties. So if you've got the same base, negative 5, and you're taking that to these powers, if I were multiplying these this expression, I need to add these powers. So this is negative 5 to the, well, 4 plus negative 4 is 0. Something to the 0 power, guess what it equals? 1. If you want to, you can simplify this and make everybody happy first. That's totally possible because you've got 5 to the 4th, positive and happy. I'm sorry, negative 5 to the 4th, positive and happy. But this negative 5 to the negative 4th power, unhappy. This wants to be in the denominator of a fraction, and once he goes there, happy. Do you notice you have the same thing, numerator, denominator? 1. Same thing here. You have 5 to the negative 2nd power to the negative 2nd power. What did we used to do when we took a power to a power? Multiply them. What's negative 2 times negative 2? You got it. It's 4. And 5 to the 4th is 6. 25. Woohoo! If you simplify this first and made people happy, this is 5 to the 2nd power in the denominator of a fraction. That to the negative 2nd power, distribute out that negative, is 1 to the negative 2nd power over 5. Now this is to the negative 4th power. Well, look at those negative exponents screaming at you. 5 to the negative 4th power wants to be in the numerator. And once he's up there, happy. 1 to the negative 2nd power is in the numerator and unhappy about it. 1 to the 2nd power wants to be in the denominator, but guess what 1 to the 2nd power is? It's 1. So you still get the answer of 625. This is just a lot easier. When you have, hold on, I gotta pause. All right, and we're back. Now, 4 to the negative 2nd power is in the denominator and screaming. Where does 4 to the 2nd power, negative 2nd power want to be? In the numerator, 4 to the 2nd power. Now the 1 is up there, but does the 1 really matter? No, because it's a multiplication problem. This literally is just 16, which I know it's a weird 16, but whatever. Letter D, 3 to the 2nd power is happy. Leave him in the numerator, happy. But 3 to the negative 1st power does not want to be in the denominator. He wants to be in the numerator as 3 to the positive 1st power. Nothing in the denominator means 1 is there, which doesn't really matter. So this is literally 3 to the 2nd power with one more 3 up there, 3 to the 3rd. Evaluate it, and you got 27. So take a second. Here are the next checkpoints. I'm going to pause the video and hopefully you get the same answers as me. All right, and we're back. How'd you do? This would be positive 8, with 8 being a whole number because 1 to the negative first power would be in the denominator, 8 to the negative first power would be in the numerator, and you would get positive 8. Here, 3 to the negative second wants to be in the numerator and become 3 to the second, which is 9. Oh, gosh, I caught myself. Good. This would be 6 to the second power because that would come down and hang out. That would make this 1 over 36. Hopefully you caught that error too. Good. This makes this 5 to the negative first power to the second power. That actually is 5 to the negative second power. That becomes 1 over 5 squared, which is 1/25. Now you're going to have to do a little bit of all of it. You're going to be multiplying, dividing, negative exponents, the whole kit and caboodle. Again, you can do this any way you want, but your answer in the end has to have positive exponents. That's the only rule. Positive exponents in the end. It's not simplified without it. So if you've got 2 w to the negative third power x, sorry, that's my best attempt. Now I've got 2wx, all of that to the second power. Remember, powers to powers, we distribute out the power to everything. This is 2 to the second power, w to the second power, and x to the second power. I took care of that parentheses, the everything to a power first. Now I'm going to go through and make sure everybody's happy. The 2 in the numerator is happy, and so is the x. Everything in the denominator is happy. 2 squared, w squared, and x, sorry, that x should be squared. But w to the third power in the numerator is really unhappy. W to the negative third power wants to be in the denominator, and once he's there, now he's happy. Well, look at what we've created. We have 2 in the numerator and x in the numerator. We've got 2 squared in the denominator. Notice the same base. And now we actually have 5 w's. 2 w squared and w to the third. And we have x squared in the denominator. Now, sorry, I'm thinking out loud. 2 to the second power is here. 2 to the second power. But guess what 2 to the second power is? It's 4. This is literally 2/4. What does that look like? A fraction. And it is exactly what a fraction would do. 1 in the numerator, 2 in the denominator, 1/2. Now, w to the fifth is as simplified as it can be because there's nothing in the numerator to cancel it out. But you've got 1x in the numerator and 2 x's in the denominator. When those simplify out and cancel out, your x is going to end up in the denominator because there's more there, and there's only going to be one of them. This would be your final answer. I don't have any repeat. I don't have any repeat bases, and I've simplified my numbers as much as I can. So let's try these ones. Look at my numbers. I've got 6 divided by 2. That really is 3. Now, I'm not subtracting my numbers. You subtract exponents when we divide. The numbers get treated like numbers, like fractions. I have f in the numerator and f to the second in the denominator. That means my f's, when I simplify them, are going to be left in the denominator, and I'm going to have one of them. The g to the negative fourth in the numerator wants to be down in the denominator. But if I put g to the fourth in the denominator and it already has a g down there, that actually makes 5 g's down there. My number is simplified, my f's and my g's are all simplified. That would be my final answer. So let's take a look at number 6. I'm taking all of this to the negative second power, and I literally mean all of this. The 3, the y, and the z. So this is 3 to the negative second power, y to the negative second power, and if I'm taking z to the second power and that to the negative second power, I multiply those powers, and a positive times a negative, all of that would be negative. Now notice every single one of my terms is negative. That means that every single one of these, 3 to the second, y to the second, z to the fourth, wants to be in the denominator. And if everything's in the denominator, 1 is in the numerator. Woohoo! Now my numbers are as simplified as they can get, but my variables are as simplified as they can get, but my numbers not. So whenever we have numbers and variables, solve those numbers. Y squared z to the fourth. And that would be your final answer. Nicely done. All right, and that's not really your assignment. That is lesson 8.3. Yay, stop.